Welcome back. We are in Khan Academy on Algebra 1 and the unit is quadratic functions and equations. We're looking at completing the square, and this tells us to rewrite this equation by completing the square. So let's do that. In order to complete the square, we need to produce a perfect square trinomial, or look for one if there is one. So if this is a perfect square trinomial, the first term is square, the last term is square, and the middle term would come about when you take a factor and square it, a binomial factor, and square it. So let's look. We've got a square term here, but the 28 is not a square term. So we're going to have to group the x's like this and come up with a perfect square that includes these two terms. Okay, so x squared plus 3x plus something is going to be a perfect square trinomial, which could be re-expressed as a binomial times a binomial where both of these are identical, which means you could express it this way. So something in here times itself is going to give you this expression. Well, x times x gives you x squared. Some number times x plus the same number times x has to give you 3. Well, that number will have to be half of 3. So 3 halves, and 3 halves are our numbers, like that. So we can write that expression as x plus 3 halves squared. X times x is x squared. 3 halves of x plus 3 halves of x is 6 halves of x, which is 3x. That gives us our middle term. And then 3 halves times 3 halves is 9 fourths. So our constant out here is 9 fourths. So if we write this expression, it includes x squared plus 3x, but it also added 9 fourths. If we want to make an equivalent expression to this one, we're going to have to add that 9 fourths to the right side of the equation as well. Let's do that. So we get x plus 3 halves squared minus 28 equals 9 fourths. So what I've done here is I've replaced the stuff in parentheses with this new term in parentheses squared, but that expression includes 9 fourths that wasn't there to begin with. So I just added 9 fourths to the left side of the equation, and to balance the equation I add the same 9 fourths to the right side. 0 plus 9 fourths is 9 fourths. Okay, now they don't want it to have this negative 28. We'll have to add the 28 to both sides of the equation, and we get x plus 3 halves. Sorry, it's being a little glitchy on me. Squared equals 28 plus 9 fourths. We would like that as a single number, so we're going to add 28 times 4 plus 9 and put that over 4. I want to know how many fourths I have in the end. So 28 times 4 is 80, and 32 is 112. And then we'll add 9. That's 121 fourths. Okay, so we want 121 fourths. All right. Let's see. We want 3 halves here. And over here we want 121 4 that, 121/4 right there. And that one's done, all right? Let's try this next one. Rewrite the function by completing the square. First thing you should do is look and see, is this a perfect square trinomial? 4x squared is a square term, 9 is a square term, so it's possible that this is a perfect square trinomial. Let's see if we can rewrite it as two binomials. So something times itself gives us 4x squared. If this is a perfect square trinomial, those will be the square root of that. If it's a perfect square trinomial, I can put the square root of my second term here. And then the sign in between would have to be the same as the middle sign because we're adding these numbers together to get our middle term. So 2x times 2x is 4x squared. 3x times 2x is 6x. Plus another 6x is 12x. And then 3 times 3 is 9. So this actually is identical. So f of x equals 2x plus 3 squared. All right? Now, that's fine, but look at the format they wanted in. They wanted us to have a 4 to not be part of the x. Okay? So if I had looked at the problem more carefully before I launched in, I would have found that I needed to factor out that 4. I need to divide everything by 4. So let's do that. So if I divide this whole expression by 4, I get, or I factor out 4, I get 4 times x squared, 4 times 3x, and 4 times 9/4. Now, so that tells us we need to put a 4 here. We want to look at this and we want to complete the square here. So, x times something has to give us a 3x for our middle term. X times x is x squared. Something times x plus the same thing times x has to equal 3x. So that'll be 3/2. So this, if we multiply by 4, this will be 4 times x squared plus 3x, but we're also adding 3/2 times 3/2, so this is this term has added 9/4. Okay, well I have the 9/4 up there, so that's okay. This expression is equivalent to that one, so I don't have to add anything out here. Nothing goes there in this case. That doesn't always happen, but because this was a perfect square trinomial, we're going to have a 0 out here. So we have 4 right there, and we have 3/2 right here, and we have 0 right there. And we're done.